Hello everyone, my name is Anurag Kumar. I am a member of Group 11 and this is the third phase of our DIY lab project. These are the group members. It is me, Anurag Kumar, Dhruv Rati, Mradul Agrawal and Rudransh Agrawal. This is the third phase of our project based on human activity recognition. In this final presentation, we will answer the questions what we accomplished, what we learned, and what's next. So, we'll start by Rudransh Agrawal explaining the data gathering process.
Yeah, so hello everyone, my name is Rudransh Agrawal and I will be explaining the data gathering conclusion in this third phase of our DIY lab assignment. So next slide please. Yeah, so on the screen you can see there is some data classification in the tabular form. So this is the data we gathered and we classified it, the ultrasonic sensor and the decibel sensor data into two classes as single person and as party. So next slide please. And now you can see that we gathered around 200 data points. So we classified the data sets as two sets as training and testing set. So we classified 75% of the data as training and 25% data set as testing set. So next slide. So on this slide, you can see the data visualization of our data set which we gathered. So we plotted it on a graph. So the data, it consists of the data gathered by the decibel sensor and the ultrasonic sensor in both cases when it is a single person or it is a party. So next slide. So on this slide, you can see the graph which we have plotted for the training and testing data. The square data points are for training and the circle data points are for testing set. So you can see the data is very random. So we are not biased with our data. So thank you. Now Mradul will continue from here.
Hello, this is Nadul and this is about our results which we obtained when we tried to classify the data which we obtained from two different ultrasonic and decibel sensors. As explained up to this point, we already had a refined data which we could use to classify and further use in our physical model. We applied a method known as SVM and tried to classify the data using it. Next slide please. These were finally the classification results we got for different parameters and learning rates. And further, when we try to modify the learning rate and parameters, next slide, we improved our accuracy and finally we got 94% of accuracy through this technique. Thanks. Anurag will continue from here.
Okay, so the other method which we use for training our model is called KNN classifiers. In our previous video, we already explained what these classifiers, how these classifiers work, and how they predict outcomes. In this conclusion section, I will tell you about the conclusions which were derived from the model. The first conclusion was that we were able to get a proper generalized performance, that is we were able to get a high test score when the number of neighbors parameter was equal to 5. So this allowed us to gain insight that reducing the number of neighbors significantly makes our model overfitting and increasing it makes our model way too simple. Then, after getting this data, we classified regions in a feature space which help us visualize the prediction and tell us how likely we are to get a certain outcome rather than the other. Finally, we took the data points which we had and we plotted them on the region which we previously derived. Over here, we can see that there is a small amount of squares which are in the region of circles. This is because our data set was real and these are few error points which were observed during that. You can see over here the blue region classifies a class 1 of our data, let's call it positive class, and the red region classifies negative class. There is a high level of accuracy which we were able to derive from using KNN classifiers to distinguish between the positive and negative classes. Now Dhruv Rate will explain the hardware implementation and the sensors which we use, and finally how we gather data from that sensors.
Hello everyone, Dhruv here. So I will conclude whatever we did for hardware implementation. So first we made an online simulation in Tinkercad, and then we bought the sensors and then made the hardware model. So in the next slide, we will show a video where I am demonstrating all the connections I made. Next slide. Hello everyone. Now I'm going to tell you about the different connections which I've made in this circuit. So first of all, let's start with the Arduino. So this is the USB cable which connects the Arduino to the laptop, and I have fed the code in the Arduino through this cable, and it gets power also through this cable. So initially I have connected the breadboard through this 5-volt output through this jumper wire, and I have connected the breadboard to the ground wire using this black jumper wire, this one which comes from here. Now this is the sound sensor. It has 3 pins. I have connected one pin to the 5-volt of the breadboard, one pin to the ground of the breadboard, and this blue pin goes to the analog A0 pin of the Arduino. This is the ultrasonic sound sensor. It has 4 pins. So one pin is connected to the 5-volt of the breadboard. The black pin is connected to the ground of the breadboard, and there are 2 more pins, trig and echo. So the trig pin is connected to the pin number 11 of the Arduino, and the echo pin is connected to the pin number 10. This is our PIR sensor. It has 3 pins. So one is connected to the 5-volt of the breadboard, and another is connected to the black pin is connected to the ground of the breadboard, and the yellow pin is connected to pin number 2 of the Arduino. Now here we have used a bulb to show that our PIR sensor is working. So this bulb is connected, we can see here, this purple wire is connecting it to pin number 13, and the resistor is connecting it to the ground. So this is our circuit. It is in on mode now, and if I show you here, so we are getting the data from the circuit. Thank you. Yes, so these are the 3 sensors we used in our project: ultrasonic sensor, sound sensor, and PIR sensor. Next slide. And this is how we get the data using these 3 simple sensors, and then we classify this data and we can do a lot of work on it. So now I would like to call Anurag to show the results of our project.
So finally, we discuss the results which we got from our model and what did we learn. After gathering our data, designing our circuit, hardware implementation of our circuit, and brainstorming different ideas together, we were able to successfully train our model. We were able to recognize the parameters which boosted the capability of our model. And finally, we were able to visualize our model in an intuitive and natural manner. The intuitive visualization or a natural visualization of our model is important because it goes to show that our model is able to achieve generalized performance easily, and which is quite nice because we didn't use many expensive sensors on this model, but we only used few cheaply available sensors, and we were able to get an accuracy of 98%. So this concludes the phase 3 of our DIY lab presentation and the complete project team project part of the DIY lab. In as an ending note, we would like to say that we liked this course very much. We got an opportunity to explore different areas which conventional course would not give us. So that was our learning experience from this project, and we thank you for that.